What's happening inside a real fax machine is surprisingly similar. There's a sensor that reads a line at a time at the sending end and a printer that prints out a line at a time at the receiving end. The lines are usually much too small to be visible, except at the tiny writing at the top of a fax, which identifies where it's come from. Of course, there's a mass of electronics underneath that converts the lines to sounds that can travel over the telephone, but the basic idea is exactly the same as our human fax. It's so simple, it was first patented 150 years ago, long before the era of electronics, and over 30 years before the invention of the phone. Bain's fax machine was inspired by an earlier discovery that paper soaked in potassium ferrocyanide turns black when electricity is passed through it. So if I put it on this metal plate and move a nail across it, it should change colour when I complete the circuit. Bain had the idea of using this paper to receive messages assembled out of printer's type. So if Rex, with a bit of help from Percy, moves his nail across the raised part of a bit of type, while I move my nail across the paper, we should be able to send the message in a series of lines, just like we did with the human fax. Of course, this time the message is being sent by pulses of electricity, so it can be sent like Morse code along telegraph lines. Bain fixed the nails at the sending and receiving ends to the pendulums of his electric clocks. This kept them in sync, however far apart they were. However, having patented the idea in 1843, he never developed it. The oldest existing fax machines are in the Musée National des Techniques in Paris. These magnificent contraptions, called Pantelégrafos, were built by a French engineer called Abbé Caselli in about 1860. They're the same idea as Bain's machine, but Caselli had perfected them, and these actually ran the world's first commercial fax service between Paris and Lyon. The message to be sent was wrapped on one of these curved plates. Instead of Bain's raised type, it was engraved out of very thin sheets of copper. These machines don't work anymore, but there would have been a stylus in here, the equivalent of our nail, to make the contact, and it was moved across the message by this large pendulum, attracted from side to side by the large electromagnets. At the receiving end, you'd put a bit of Bain's soggy paper on one of these curved plates with another stylus resting on it. Then, if you got the two pendulums swinging together, the message could be reproduced. In practice, getting the pendulums to swing together 250 miles apart wasn't at all easy. They had to have a separate clockwork chronometer at each end to get them in sync before the message could be sent. The definition the Pantelégraph achieved is really quite extraordinary. Unfortunately, though, it was too far ahead of its time.
Every available development of science and engineering has been utilized to get the story to the reader in the shortest possible time. And now, the latest miracle of news gathering, sending pictures by wire, has lifted the curtain on a new era in newspaper history. It is only a matter of minutes after a news event has occurred before newspapers all over the country are carrying pictures that tell the story more graphically and completely than the printed word, by simply picking up a telephone and calling the paper.
Most of these machines work by wrapping the picture around a drum and then moving a single sensor slowly along it. This model shows the basic idea. The page transformed into a string of black and white bits and then all recombined at the receiving end.